So have you ever thought about microwaving bacteria? No? Well, maybe we should. We're going to talk all about that today on today's episode of Short Stories of Bacteria. Hey, what's up, everybody? Welcome back to another episode of Short Stories of Bacteria. I, as always, am your host, Dr. Hay. I'm here to guide you through yet another fun and incredible story about the lives of the tiny and infamous, that would be, of course, the amazing and informative, the fascinating bacteria. If this is your first or second or third time, whatever time it is, whether or not you're listening to us on the podcast or whether or not you're watching us over here on YouTube, don't forget to hit that like, share, subscribe button. Don't forget to give us a 5-star review and follow us and share us with all of your friends and family as a way of spreading the word on the channel and on the podcast. But enough of this logical nonsense. Let's move on to the science, Dr. K, you say, all a thwack. So let's talk about this. The broader conversation that we're having is one about what's called bacterial transformation. We're going to talk about what that means in a second. Because right now you're probably wondering, well, gee, Dr. K, why would someone want to go about microwaving a bacteria? That seems kind of counterintuitive. And the reason why has to, again, to do with this concept of bacterial transformation. There's this really neat new paper that came out of RMIT University. RMIT University is not the Massachusetts Institute of Technology, as it turns out. That's actually a university in Melbourne, Australia. So that's very exciting. But what is the whole point of this? Let's jump into the actual science here. So in order to understand this, we need to spend a little bit of time talking about bacteria and how they deal with their environment. So bacteria, they run into a whole bunch of different things in their environment, as you may be well aware. They run into things like viruses. They run into things like, antibiotics. They run into things like other bacteria, right? A whole bunch of different environmental cues, just different environmental entities, we'll call them. And a lot of these environmental entities are very dangerous to the bacteria. Obviously, antibiotics cause them to die. Viruses cause them to die. Other bacteria cause them to die. Just changes in environment tend to cause bacteria to die. And so what that means then is that bacteria are pretty consistently under a very strong evolutionary pressure to adapt. Right? There's always some kind of environmental change that's very, very nearby that's going to cause bacteria to want to evolve and adapt to their environment. Okay? So that's the first big point. Now, how is it that bacteria deal with this? How is it that bacteria can react and change and evolve to these altered environments? And there's a bunch of different ways, but one of the best ways is they have this ability to incorporate foreign bits of DNA. Right, let's give an example. So let's say you have a bunch of bacteria, right? And they're just kind of trundling along in a nice big chunk, right? And they're moving around and they run into an an antibiotic or something like this. Now, the antibiotic is going to start killing a whole bunch of different bacteria. So that's very sad for the bacteria. But sometimes what bacteria can do is they can reach out and then pull in DNA from their environment. Now, let's say then that a bacteria, by happenstance, grabs a hold of a piece of DNA that encodes some kind of protein that allows it to push that antibiotic away or stymie that antibiotic or break that antibiotic, something like this. Now, all of a sudden, this bacteria has the ability to fight off that antibiotic, and it can now pass that ability on to other bacteria, right? So bacteria have this really cool ability of incorporating bits of foreign DNA, either just environmental DNA or DNA from a different kind of bacteria. You guys maybe have seen pictures in like high school textbooks or chemistry textbooks, in college textbooks, where it's like a little bacteria, right? And then there's a little tube that connects this one bacteria to a second bacteria, and they talk about something like bacterial conjugation, how bacteria are able to transfer bits of DNA from one to the other as a way of passaging something like an antibiotic resistance gene or some kind of resistance to a virus or something like this. So bacteria overall have this neat ability to incorporate foreign bits of environmental or other bacterial DNA as a way of adapting and evolving to these changes in environment. Now, that's very, very cool. It's a neat ability. Sometimes it's very difficult to deal with bacteria that can do that with something like antibiotic resistance. But in spite of it being frustrating to deal with, especially on the medical scale, scientists, researchers can utilize bacteria's ability to take in this DNA as a way of providing therapeutics, right? So think about it this way. We talked about how let's say a bacteria is trundling along and it runs into an antibiotic. And so then it pulls an environmental gene that allows it to fight off that antibiotic. Now imagine then, what if we could give bacteria a piece of DNA, and then that DNA encoded some protein that we wanted, and then the bacteria would just take the bit of environmental DNA that we just gave it, right? And then make that protein or whatever it is that we want and make it for us, right? Now that's the concept behind production of something like insulin, as it turns out, right? What we can do is we can give bacteria a gene or a piece of DNA that encodes insulin, right? And then bacteria can mass produce that insulin, and then we can extract that insulin and then use it in the medical context, right? So it becomes really useful for scientists, doctors, and researchers, doctors, scientists, and researchers and doctors and scientists. It becomes really useful for us to be able to use this or manipulate this ability of bacteria to take in environmental DNA and force bacteria to make stuff that we want. Okay? Now, bacteria don't always want to take in environmental DNA. Like, they always have that ability, but they don't always want to take in this environmental DNA. And so a problem for a lot of researchers is making it such that bacteria really want to take in a piece of specific DNA. And there's a number of different techniques that researchers use as a way of kind of force feeding, for lack of a better phrase, force feeding bacteria this bit of DNA. So one of them is what's called heat shocking, right? So what you do is you take a little piece of bacteria, you take a bacteria or a series of bacteria, right? And then you dunk it into a warm water bath. Usually it's like 42 degrees Celsius or something like this, right? And then what that does is that starts to, for lack of a better phrase, loosen up the membrane, the little lipid bilayer that surrounds the bacteria, right? And what that does is that allows the DNA that you want to kind of force feed the bacteria to kind of enter into the bacteria of interest, right? So that's one way of giving DNA, by heating it up to the point where they just kind of pull in an environmental piece of DNA. That's one way. The second way is a little more drastic, but it works a little bit more effectively, and this is what's called electroporation. So electroporation is kind of like heat shock, except instead of heating up the bacteria by increasing the temperature, putting them in a hot water bath, what you do is you essentially just electrocute the bacteria. You put them in a little tiny container, you press a button, you yell, something that Victor Frankenstein would say, and then you zap the bacteria, and then that causes the bacteria to pull the DNA in. Okay? So those are a couple different ways. The problem with those ways is that they tend to kill a lot of bacteria, right? If you heat them up really quickly, there's a bunch of bacteria that are just going to die, right? And if you electrocute the bacteria, there's a bunch of different bacteria that are going to die, right? And so there's a question out there in the scientific community of like, okay, is there a better way for us to transform these bacteria? Is there a better way for us to give DNA to the bacteria such that they can make what we want? And this is where the paper came in from RMIT University. Again, the university in Melbourne, not associated with Massachusetts Institute of Technology. And what they came up with was this really whacked out idea of using microwaves. Now, microwaves, you may be aware of this. Turns out microwaves are a type of electromagnetic radiation. So there's a whole bunch of different kinds of electromagnetic radiation. There's like visible light side, there's gamma rays, there's ultraviolet rays, there's radio waves, right? And one of them is microwave. You may recognize that from heating up something in the microwave. Now, what the researchers were thinking to themselves, like, okay, whenever we hit something with waves, we're passing a little bit of energy into it, kind of like if we were to heat something up or if we were going to electrocute it. And so what the researchers were like, hey, let's try microwaving these bacteria in gradually increasing amounts, and let's see if that increases their ability to take in this environmental DNA. That was their idea. So what they did is they whipped up a gene, and this gene, it allows bacteria to essentially glow under certain contexts, right? So they got this gene together that allows bacteria to glow. They put it in the environment. Then they microwave the bacteria with that gene for, I think it was something like 3 minutes. Let me check. Yeah, 3 minutes, but it was on like a really, really low power setting. You can kind of think about it that way. And then after they put them in like what's called recovery media, which is essentially just kind of like beef broth, right? After that, they put them on a plate and then let the bacteria grow. And lo and behold, not only did some of the bacteria glow, they actually did a better job picking up that DNA, that glowing DNA, than these other methods that I've talked about, the heat shock and the electroporation. It's really, really cool. And so what that means then is that there's this emerging technology, there's this emerging protocol that's going to allow scientists, researchers, doctors to be able to more efficiently transform bacteria. And once they are more efficiently able to transform bacteria, then that means they're more efficiently able to mass produce these proteins that we want at a larger scale. Anyway, so let's wrap this up. Big points. Number one, bacteria swallow DNA as a way of expressing certain types of genes, and they do that as a way of adapting to their environment. Number two, scientists can use this behavior as a way of making bacteria produce unique and useful materials, including things like insulin, like we talked about. Number three, as a way that there are a lot of different techniques in the scientific field are geared towards getting bacteria to accept the DNA that we want it to accept. And finally, number four, there's a new way that came out just a month or two ago that involved microwaving the bacteria, which results in a greater survival and better transformation efficiency of our bacteria. Again, it's a really, really neat instance of how just the protocols around bacterial transformation and just manipulation of DNA and protein within the context of bacteria is still a growing and evolving field. But guys, that is all I have time for today. I hope you guys enjoyed it. I hope you guys learned something. I had an absolute blast. I hope you guys did as well. And I hope you guys will tune in again next time for another episode of Short Stories of Bacteria.
Hey everyone, thanks for watching that video. If you guys enjoyed it, if you liked what you saw, don't forget to hit that like, share, subscribe button, and I will hopefully see you guys in the next video. Later!